Good evening, everyone, and thank you once again for joining me for another program of the Arkansas Valley Audubon Society. My name is Bree Pappan, and I'm the Museum Services Coordinator here at the Pueblo City County Library District in Pueblo, Colorado. And I am joined once again by Peg Rooney from AVAS. Thank you, Peggy, for joining us tonight.
Sure.
We are going to be talking about and viewing a fantastic video by Maggie Gaddis. And so, Peggy, why don't you go ahead and tell us about the video?
Sure. Thanks, Bree. First, I want to welcome you here and to remind you that grasslands are the fastest disappearing ecosystem in the world. And it's primarily due to human development. And that's really a shame because grasslands are so important. They act as carbon sinks, so they'll sequester carbon in the soil, which mitigates the effects of global warming. They'll prevent soil erosion, they'll protect our rivers and streams, and they provide wildlife habitat for eagles and grouse, burrowing owls, pronghorns, pollinators of all kinds, and even in the southeast, a herd of desert bighorn sheep. And they're beautiful. Abundant wildflowers, vistas as far as you can see, red rock canyons with perennial springs. And so grasslands are worthy of our respect and our protection. And you can help protect those habitats and the critters who live on them by joining the Arkansas Valley Audubon Society. We have membership information on our website, Southern Colorado Birds, abbreviated SOCO, so socobirds.org. And now we'll listen to this recording on grassland ecology. And Maggie Gaddis is an ecologist and the president of the Colorado Native Plant Society. So let's hear about grasslands and how we can protect them. Are you ready, Bree?
I am. Here it is.
Okay, good deal.
Hello, my name is Maggie Gaddis, and today we're going to chat about grassland ecology. To get started, let's put ourselves on the map. I am talking to you from southern Colorado at the foot of Pikes Peak, America's Mountain. We are right at the interface between the plains and the foothills, and this here is the Garden of the Gods Park. In our agenda today, we'll discuss the ecology of grasslands, we'll review several common species in the Pikes Peak region, and we'll look at Weber, Ackerfield, and Wingate, leading authors, to understand grass vocabulary, botanical vocabulary that facilitates understanding the identification of grasses. So here in Colorado, we are very lucky because we have almost 10,000 feet of elevation change in our state. What you're looking at here is, I think, the Sangres, or I'm not entirely sure because I have taken many pictures over the years, but there aren't too many mountain ranges in the state that take on this kind of singular range appearance. Anyway, as we can see on the lowest elevations on either side of the picture, we have a treeless landscape. And then at the tops of the mountains, we also have a treeless landscape. In the plains, in the lowlands, and in the alpine, in the highlands, we have no trees, and this is an indication of how dry the landscape is. Of course, the landscape is dry for different reasons in these two life zones, but it's just something interesting to note. When you're thinking about the plants in Colorado, you can think about the stature of the plants as an indication of how much moisture is available. In between the plains and the alpine, we have three life zones. We have the foothills, the montane, and the subalpine. Today, I'll be talking to you primarily about species and ecological principles that apply in the plains and the foothills. So let's first get ourselves thinking about what ecology means. So take a moment to write down your definition of ecology. All right, now I'm going to show you a definition. This is really common definition. The study of how organisms interact with their environment. I don't mind this definition, but it sets up a dichotomy that I don't think is an accurate representation of the science. So, a lot of times we think about the environment as being a static principle and the organisms are reacting to it, but there are organisms in the environment. So, I prefer this definition. Ecology is the interaction between abiotic and biotic factors in the environment. And abiotic factors are non living, and biotic factors are living. So now let's take a look at this picture. So to really kind of internalize and call out what are the biotic and abiotic factors. When I look at this picture, I first, of course, notice the ominous clouds, which in Colorado usually represent some kind of building of moisture in summer, leading to a thunderstorm in the late afternoon. And then also I can see that there's a river, and I can see that the landscape is rather flat, and the river is sinuous. It's bendy and windy, and that tells me that it's as a pretty free flowing river as far as rivers go. Also, I can see that that river is wide. It is probably a second order stream. Primary order streams are small streams at the tops of watersheds. So when I focused a lot of my abiotic discussion on the moisture and the water in the picture, but of course there's other things we can't see like the basement soils. Now thinking about the biotic factors, there's a lot going on. So we have two life zones in the picture. We have the grasslands in the foreground, and we have a riparian life zone in the background. So those trees that are, I can't really tell if they haven't leafed out or if they're senescing, but those are cottonwoods, and they are facultative phreatophytes. They're the only tree native to the plains ecosystem, but they are actually native to the riparian ecosystem, the riparian life zone that travels through all of the other life zones. And then we see in the middle ground that there's this manicured landscape of grass, and it looks like a monoculture. And then in the foreground, we see a more wild scape of grass. The plants have more heterogeneity, and you can see that they're on the right, bottom right, there is a railroad bed right here. And so there's some kind of uh, feature that's dividing the landscape right there. So ecology is the interaction between the abiotic and biotic factors in the environment. And when we look at a picture, we should start to think about teasing those out. So in the grassland, there are certain characteristics that typify the ecosystem. So in grasslands, we typically have mild slopes, lots of solar radiation, and wild swings in temperature. This is true pretty much anywhere in Colorado due to our elevation. But in the grasslands, we can have over 100-degree temperature change. The average rainfall is 12 to 15 inches per year. Now, this is just very little compared to many other life zones in the world. And also, it's important to note that the 12 to 15 inches of rain don't fall in equal quantities per month. There could be several months where there's no rain at all, and we go into a very xeric landscape. Also, fire is a very important factor in the grasslands. Several of the pictures I will show you would indicate that the fire regime has been suppressed. And some easy indications of this are an abundance of woody materials in the grassland, for example, yucca and sagebrush. In the grassland, soils are slightly alkaline and they're medium to fine texture. And this has to do with the limestone basement rocks that are common around here. In the grasslands, we have lots of grasses, the primary biotic features, but there are many others. Don't worry, I have them all in store for you. Grasses have jointed, hollow stems and clusters of small membranous flowers arranged in spikelets. Grasses have fibrous roots, low lignin content, and annual leaves. And all of these features lead to rather decent soil development. And this is especially as compared to other life zones in Colorado where conifers typify the overstory of the landscape and needles behave very differently than deciduous leaves. So we can see here in this picture in the middle, A represents a fibrous root system and B represents a taproot system. And they're two different means of sequestering moisture. In a fibrous root system, there is a lot of surface area to take advantage of ephemeral precipitation that comes sometimes in deluges but does not come very often. And then the taproot is a different evolutionary adaptation for storing water in the plant organ. Grasses can be perennial or annual. Most native grasses are perennial, and some terrible invasives are annuals, most notably cheatgrass. Perennial plants live from year to year, and annual plants propagate via seeds only. So, of course, also there are many beautiful flowers in the grasslands, and we have another video out about the wildflowers, and I will just skip right over this. But if you want to take note of my iNaturalist account name, it's EcoCity Colorado Springs. Biotic factors also include animals. The primary ecosystem manager in the grasslands is absent, and that is bison. The action of hooves, grazing, and poop contribute to grassland renewal. And we might wonder, are cows a good substitute? This could be a very lengthy sidebar in a lecture, so I will let you to do your own research. If you look at the Prairie Ecologist article that I have noted here, it gives some interesting feedback and commentary on the topic. Now, if we think about this reference on the right about management intensive grazing on irrigated pasture, we can think about how management can, it's not that cows are bad and bison are good, it's how we manage them. The way we manage our grasslands in an agricultural setting really relates to this grassland renewal. How can we mimic the behaviors of bison such that the grass is self-renewing in the ways that it has evolved to act with its primary ecosystem manager, the bison. So, for example, when you graze a field to 90% use, the grass just completely stops growing for 2 to 3 weeks. When you allow grazing to occur to roughly 70%, we have 50% dormancy in the grass. And if, however, you graze a plot to 50% use, the roots never stop growing, and the plant is recharged by the grazing effort. The grazing actually stimulates growth. The other thing to note that is interesting concept to keep in the back of your mind, even in your home garden landscape, the length of the above ground parts of grass relates to the length of the below ground parts. So if you, for example, can tolerate your lawn mowed to 4 or 5 inches, it will be a more drought tolerant lawn because it will have more fibrous roots. If you prefer, a golf tee, you're going to have a harder time keeping that grass moist because there will be less roots to take up the available moisture. So, in addition to large mammals like bison, there are myriad small mammals in the grassland, and they assist with the mechanical breakdown of carboniferous material, insect control, and prey for wrappers and seed dispersal. So, what I have shown you over here on the right is just part of a table from a Colorado Natural Heritage Program biodiversity tracking and conservation system. Take a look at how many different species there are of pocket gophers. Who knew? But this is an example of how diverse the grassland is. Two species cannot coexist in the same niche. And there's a principle of ecology called the competitive exclusion principle. But this should really express to us that there are so many different niches in the grassland. In the grassland, we have bears, wolves, coyotes, mountain lions, ungulates, birds, reptiles. The grassland is a very diverse place. Now, still more biotic factors. So in the soil, which we might think of as being not alive, it's actually very alive. There are so many microorganisms and fungi in soil that are facilitating the process of primary production. So, mycorrhizae is a mutually symbiotic association between fungus and a plant. And I put that little question mark there because there is some argument in the literature about whether this relationship is truly symbiotic or if the mycorrhizae are parasitic to some extent. But essentially, as I mentioned before, there again we see that A and B root structures photo. When we think about what the fungal association is doing, it's vastly increasing the surface area of plant roots, which facilitates the exchange of moisture and nutrients. Also, we find that the near root environment has a plethora of microorganisms, bacteria, that are helping to assimilate and convert chemicals for plant uptake. So, when we think about the soil microbiota, there's so much going on there. And this is, in fact, one of the reasons why I became an ecologist. I took a soils class and I had this aha moment that, the ultimate expression of what's going on in the ecosystem is uh, illustrated in what is happening in the soil. So let's just take a journey and I'll read you this story I wrote. No-till agriculture is of great interest to scientists and community members at the Land Institute in Salina, Kansas, who are attempting to develop perennial agricultural grains from native grass species. Conventional agriculture requires fossil fuels in several ways while also releasing carbon from the soil. Perennial grasslands are carbon sinks because carbon is stored in the root systems, and over time, more carbon is stored than is released in cellular respiration. When we till the fields for the next year's crops, the plants are sacrificed, and thus all carbon sequestration ceases. Furthermore, the carbon in the root systems decomposes more rapidly because of the mechanical breakdown of the plant material coupled with the introduction of oxygen into the soil. Both fuel the cellular respiration of the soil microbes eating the plant material, which is called decomposition. The field itself becomes a carbon source. While writing this for the first time, I envisioned the soil microorganisms grazing like cows in a grassland. Essentially, the soil microbes and cows are doing the same thing. Both are animals, both require oxygen for metabolic processes, and both respire carbon containing compounds. Both consume plant matter. A big difference to note is that cows exhale methane, a super powerful greenhouse gas, while soil organisms respire carbon dioxide. Getting back to the carbon balance of conventional agriculture, the fuel used to run the super tractors to till monoculture fields comes from ancient plants and animals. These fossil fuels are carbon sinks as well. When combusted, they too release carbon into the atmosphere. This is a double whammy. Soil carbon and ancient carbon is released in conventional agriculture. The whole process of growing plants becomes a carbon source. It sounds paradoxical. If we could adopt perennial agricultural practices in a number of food sectors, we could slow climate change. We could keep the carbon in the plants and soil and avoid consuming fossil fuels in the management of the agricultural system. So, as delicate and interwoven as this ecological dynamic is in a grassland, there are numerous threats to the grasslands because guess who else likes to live here? We do. So, in the next several slides, I'm going to take you through thinking about how our behaviors on the landscape create a threat to the grasslands. So, of course, we can start here. This is my family farm, actually, east of Longmont, which historically my family were dairy farmers in Kansas, and they moved to Colorado and started. This is an alfalfa farm for as long as I can remember. And there was always an oil rig on the farm, not always, but in our lifetimes. And in the last decade, there is now a fracking operation. And so the number one threat to our grasslands is natural resource development. I just talked about the gasoline we need to drive the tractors to till the fields. This is how we get it, and this is the result of domestic oil exploration. On the grasslands, we also graze our cattle. And so what we see here, we see that barrier again in the foreground. This time it's a fence line. And so beyond the fence line, we have a degraded grazed system, much like the one we looked at the very beginning of the talk, but that was near a river. And here we are in the desert. And one thing we have done with our public lands in the last century is we've used them. We have created a conservation ethic in which we are putting our lands to work, hopefully for the good of many generations. But grazing in the desert, that's a questionable practice. And I just mentioned the fence row again because um, it is oftentimes that in the road easements, we have the greatest diversity of grasses because that landscape hasn't really been perturbed by whatever land management scheme is going on beyond. Then, of course, in our grasslands, we have a great plethora of roads. And in fact, it was the roads and the strategizing of Roosevelt, Rockefeller, and Ford that brought Americans to the American West. It was part of our settlement of this great country. But we see all sorts of things change in our landscapes with roads. We see animals moving across them and some animals not moving across them, so habitat fragmentation. We also see like the aggregation of moisture, so we can have weed corridors that are associated with the sheeting moisture off of the rains. And then, of course, we have other deposition of automobile related chemicals into our water sources when our roads come close to our waterways. Now, of course, many of us chose to come out to the American West. We chose to come out here for our love of recreation and nature, but we are loving our lands to death. And this is an example, this is a picture in the Garden of the Gods where we have more traffic than almost any other public land in the United States. It is the busiest city park, and we have as much visitation as Rocky Mountain National Park. But the Garden of the Gods, 2.5 square miles in the middle of the city, and Rocky Mountain is 25 square miles, same number of people. So what we find in our grasslands is that it's a very resilient system until there's a lot of impact, right? And right here, the impact is simply walking. So as we walk over the grasses, they're degraded, and the soil is then no longer being held by their fibrous roots. And then the deluge of monsoon rains come, and we find that we have great erosion problems. More about our need for energy. In the American West, we have in the last decade really increased our efforts to have domestic resources for renewable energy. And this sounds wonderful. However, there are consequences. This is the solar thermal generating facility on the border of Nevada and California in the Mojave Desert. And so on the ground, there are just thousands of panels, and they're actually reflecting the light up into these towers. But if a bird flies through that white haze, which is actually energy, birds are incinerated. There are also imperiled tortoises that live here, and so easy. We use the land and we have lots of moving parts that we need to keep track of. Then, of course, there's agriculture itself. And I was recently on a road trip and I learned from seeing this, which is a cotton field, that we love to irrigate our dry lands to provide agricultural opportunity. And who knew the best long staple cotton in the world comes from the American West, where it is irrigated 100%, and where cotton can mature to a better quality because there's no moisture in the air, so there's no moisture damage. So we're always thinking about the things we buy, the things we need, the places we go, and they're largely having an impact on our plains ecosystems. And then finally we have weeds, right? We like to move around with the plants that we love, and sometimes we have ideas about these plants that turn out to be not so true. So on the left we have cheatgrass, which was planted. It greens up so early. It seemed like a great idea, great forage to get the grazing season going on the rangelands in the American West. But as we all know, cheatgrass is a winter annual, and it only looks this luscious for a few weeks in the early spring, and at which time it steals the resources, steals the niche, and by the time the summer is in full force, the cheatgrass has gone to seed, and the landscape is barren. In the top right, we have Canada thistle, another pervasive weed. Oh, I will stop and say the cheatgrass is an annual, so its extensive invasion is simply due to a lack of seed management. If we could figure out how to manage the seed bank, we could start to have an impact with cheatgrass. That's my opinion. Lots of people disagree with that. There are very intense management applications to fight cheatgrass, the most recent of which I've heard is to poison the top several inches of the soil because some ecologists believe that the native seed bank is lower. It's lower down in the soil, but the cheatgrass seeds are right on the top. I'm not sure I agree with that one. I'll have to think about that more. Um, but here's a species where it's more compelling the use of herbicide, and that is Canada thistle in the top right, which is a perennial with rhizomes, so a connected root system. And so when you mechanically remove Canada thistle, most notably, any root fragment can become a new plant. So you could never harvest this plant as a weed removal tactic and put the plant anywhere else, like in a compost pile or in a dump, because it will spread. And it is I have seen many pollinators appreciating Canada thistle, so I think that is its one upside. But generally, it invades in the mesic riparian areas, in irrigation ditches, and it is almost impossible to remove. And then in the lower right, we have another pernicious annual, the kochia, which probably was brought to America about the same time as the cheatgrass, and the leaves have a really high nitrogen content, so it's kind of referred to as poor man's alfalfa. The thought was that kochia would help to renew the range, but in fact, it just sucks up the nutrients and leaves nothing behind. And then finally, of course, there's us and our trappings in our landscapes. So here we see a completely converted landscape in my neighborhood. We have pavement everywhere. We have rocks instead of vegetation. We have Kentucky bluegrass. We have deciduous, temperate life zone species for trees. Almost nothing here is native except an occasional, blue spruce in a bank parking lot. I hope I haven't depressed you too much. Our grasslands are in dire straits and they need help. And hopefully your interest in grasses will help help to restore them. One thing that really helps is to
Know what
know
the
what the
grasses
grasses
are.
are. And so we are going to transition now to talking about grass anatomy and looking at these species identified.
And that was fascinating. I had no idea about the dynamics of the grasslands and how essential they are. And that's amazing. And it makes me want to continue to watch and learn about the grasslands, especially in Colorado and this whole area where developing is constant, especially as you get more northern in Colorado, and they're depleting grasslands and open lands and wildlands, especially wildflower species that are depleting and necessary for our ecosystem.
And people can learn more about native plants and how they can plant them in their yards and gardens by going to the Colorado Native Plant Society website, CONIPS, CONPS.org. So join the Audubon Society and join the Native Plant Society.
Yes, I have shared the conps.org website in our comments, as well as the AVAS website and the SoCo Birds Organization website. Peg, can you talk to our viewers a little bit about what our programming in the future will be like?
Sure. We're going to take July off and enjoy some sunshine and a little bit of travel. And then we'll resume our virtual programming in August. And we have some interesting upcoming programs that we hope to have for you. And that would include bats of Colorado, wasps. Wasps of Colorado, we think of them as terrible, but actually they're quite good pollinators, and some very interesting facts about that. And then we'll come up with some other interesting topics as time goes on.
Wonderful. Thank you so much. And thank you again, viewers, for joining us tonight. And we appreciate all the contributions that you've made, Peggy. This year, we so enjoy having you being a part of our virtual programming and special collections, and learning as much as we have up to this point. So again, thank you so much for joining me, and have a good evening.
See ya.
Bye-bye.